And our next speaker will be Tatiana, who is a PhD candidate, again, from Biomaterials. And she will continue this session on bio-based materials. Right. Stage is yours.
Good morning, everybody. My name is Tatiana, and I'm doing my PhD in natural materials and the possibility of developing more sustainable building systems for architecture. Okay. So currently, the search for new sustainable construction practice has explored the possibility of using natural materials or green materials. The excessive consumption of non-renewable resources has generated high amount of pollution. This paradigm needs to be changed. So the use of green materials is intended to introduce a new construction system totally biodegradable, reusable, and recyclable. So this research focuses on the exploration of the new materials, so recyclable, biodegradable, and reusable materials. So the fishing industry produces tons of waste every year that is not used. So like shellfish shells, fish scales, squids, fungal cells, they are rich in chitin. This is obtained by a chemical process that can originate other material, the chitosan. So this product is natural, is low cost, renewable, and biodegradable. So the aim of this research focus on the search for a natural material, and I separate my research in 3 groups. So each mixture is composed of a set of materials like water, cornstarch, glycerin, chitosan, acid acetic, and maybe calcium carbonate. So I study different mixtures with different proportions of materials. For example, the group 1 studies the equal proportion of starch and chitosan. Group 2, more chitosan than starch, and group 3, more starch than chitosan. This is the materials obtained for the different mixtures. So the group 1, chitosan equals starch, mixture A and D, more chitosan V and A, and more starch C and F. So in this graph, we can show the proportions of the materials, and it's clear, we clearly understand that some mixtures don't have cellulose and others have, So mixtures with high proportion of chitosan, others lower. So in the graph 2, we can show the properties of the material after drying. Some mixtures without calcium carbonate are more transparent and have others have stronger brownish color. So here in this image, it is possible to observe the behavior between a mixture with glycerin, the left image, and without glycerin, the left image, and with glycerin, the right image. So in order to test the printability of an object using the 3D printing, I made the initial test. I called the shape 1. It was defined which consisted of printing a regular grid with 1 layer. The test aims to test the printability, the viscosity of the material, and check the shrinkage index of the material. Here is an image shows printing the regular grid on a flat surface using the Luton Mini 2.0. with air pressure of 1 bar. It was decided to print on a film to easily move the mixtures and put in a mold if I want to shape them. So other image, other perspective of the print. So in this image, both of you can watch the finish of the grids obtained the objects produced with different mixtures. So the grid on the left was produced with a mixture D that is composed of 4 starch, chitosan, and calcium carbonate. And the grid on the right was produced with mixture A, starch and chitosan. The difference in color is essentially due to the presence of the calcium carbonate in the left grid, because it's a powder and a white powder. Here we can see different objects produced with different mixtures. And we can watch the shapes and the opacities and the difference of the color. So it's intended to see if it is possible molding the objects, and I put the grid inside of a mold, and after 2 days the object was found to have the same shape of the mold. So in summary, after running these tests, I can conclude that the printing on a film allowed to easily mold the object. The air pressure used is almost 1 bar, which means that the fluidity of the material is really high. So the proportion of chitosan and calcium carbonates influence the final finish of the objects, and the presence of glycerin influences the hardness of the material. So now after explore that mixtures and a way of controlling the fluidity of the material, I try to explore more mixtures where I refine the mixture and introduce a new material, powdered cellulose. The same parameters were studied, and for compared materials. So I've made the one graph on other graphs that it's possible to observe that the percentage of the cellulose in the mixtures is high compared to other materials, and the strength increased a lot. So in order to test the printability of the objects, I made a second test that consisted in printing an irregular wavy grid with 4 overlapping layers. So to test, I test the printability, the viscosity of the material, and the shrinkage of the material. So here is a picture, demonstrates the printing of the irregular grid using the Luton 2.0 that is composed different from the first one, is with cellulose, starch, chitosan, glycerin. And this video, it's possible to observe the prints of the grid. So after printing the previous grid, I put the irregular grid into a mold, and the grid acquires the shape like the image that you can see. Through the observation of the image, it is possible to observe that the rigidity, the hardness of the shape acquired the object after trying, and here we can. Since it was of my interest to explore mixtures with cellulose, the behavior between 2 objects was compared. So I intend to explore the possibility of using or a mesh with or a grid, a hard grid and a flexible grid. So the difference between both of them is the left grid is composed of cellulose, glycerin, starch, chitosan, and the right grid it's composed with cellulose, starch, and chitosan. So it's possible to observe although they have the same mixture, the behavior is different. So to check the behavior of the two grids, a central force was applied on both objects. The left grid deforms easily and doesn't recover the shape, and the right grid has more difficulty of deforming and starting to break if I increase the strength. So this is because the left has glycerin and the right doesn't. Another video that we can see the flexibility and the rigidity of the two flat mesh. So the left mesh contains glycerin and the right mesh doesn't. So in summary, after running the second test, it is possible to conclude that the presence of cellulose strongly influences the hardness of the material. The percentage of chitosan introduced in the mixture influences the final color of the object, and the hardness. The presence of glycerin influences the flexibility of the material. And although improved, the fluidity of the material is still high, so I need to decrease a little bit more to print with much more layers. So this is the last test I've done. It's the main point was to print in other mixture, a flexible mixture. So the main point was to use a hardness mixture with a flexible mixture. And this image shows the grid print on a flat surface. And this video shows the printing of the rigid mixed over the flexible mixture and the joining of both of them. The final result, after drying the image shows the final finish of the obtained pieces, and the base mixture is flexible and because have glycerin, and is translucent because doesn't have calcium carbonate. The grid mixture is rigid and doesn't have glycerin and is more opaque. If I put my hand behind the object, it's translucent in some parts. Other image that shows the final finish of the piece. So concluding the presentation, so my goal is to increase the overlap of layers, decrease the fluidity of the mixture to increase the layer overlaps, decrease the shrinkage index of the object in high, not in the base, and test maybe printing in the curved surfaces and not in a flat surface. At the end of the day, we will organize a workshop with natural materials, and we will demonstrate the possibility of printing with cellulose and among other materials, my mixtures and Dunia mixtures. And the main point of the session is to see the material properties, the shrinkage, and the buildability of the mixtures. So thank you, and sorry for my English. No, if they have glycerin, yes, but if they don't, they maintain the shape. Sorry. The question was if my pieces after a while lose the shape. So my question is the application of my material. So this is a good question because I don't know. I'm in the phase that I'm exploring the material and I don't know the future use, but I want to create something like more like a blocking, I don't know, a sunblock, like that, but I don't know. It's the next step to take. Or maybe just for just design, I don't know. Yeah, we need to study this part.
We have stabilize everything, and then it could bring inside the medium and that's the more that you want. But it would react to any material or not. I don't know, but you can look into that. Powerful. Okay.
Glycerin. Yeah, the amount of glycerin will increase the flexibility of material. No, but I will show you, but I will show in the afternoon, in the workshop. Yeah. Yeah. Thank you. Yeah. No, I don't start investigate today, but I need, because I need to change my mixers to print, to have possibility of printing in more layers.